field is positive, the vector is pointing upward, away from the Earth ground. Although the E field in volt per meter was calculated based on delta V between the electrodes and the saturation delta S, the E field is active between the electrodes. With the larger disk, positive electrode larger than the negative electrode, it opens up the E field to extend beyond the electrodes as a physical phenomenon. Electrostatic force interaction is inverse square law. F equal to K times Q times small q divided by distance square. E equal to F divided by Q equal to K times big Q divided by D square. The electric field is also inverse square law. Further away from the E field source, the weaker the force. Due to inverse square law, the net electric field force exerts onto the earth ground when the craft is lifted at D equal to 10 meter height is 1 over 10 square equal to 1 over 100. The electric field is weakened attenuated by 0.01. So E over D square equal to F over Q D square equal to 38,400 newtons per 1 coulomb per 100 equal to 384 newton per coulomb per meter square, equivalent to lifting M equal to F divided by G equal to 384 newton divided by 9.8 meter per second square equal to 39.1837 kilograms. This calculation indicated that the electric field on the Alex lift craft is sufficient to lift its weight at 10 meter height after discounted the distance from the earth ground height effect. In summary, the Alex Chestercott lift craft requires these parts: magnet DX08 N42 1-inch diameter, 0.5 inches thick, 12 numbers. Magnet mount 1-inch diameter, number 8-32 male thread stud, 12 numbers. Motor 12 volt DC, 7,380 RPM, 2 numbers. Aluminum CD disc, 12 cm diameter, 0.1 mm thick, 2 nano, 2 numbers. Aluminum large disc, 24 cm diameter, 0.1 mm thick, 2 nano coat, 1 number. Steel rod, screw thread, 4 mm diameter, 250 mm length, 3 numbers. Nut, female, 4 mm diameter thread, 18 numbers. Washer, 4 mm inner diameter, 18. Rubber cushion, 4 mm inner diameter, 6 numbers. Electric charge on craft. The craft is 1.5892 kg. Dynamic weight 1.446 kg. And a test charge Q equal to 1 coulomb is a large quantity. 1 coulomb equal to 1 over 1.6021 times 10 to the power 19 electrons and protons equal to 0.6242 times 10 to the power 19 electrons, protons. I need to find out how much test charge Q is required. to levitate the craft. In Alex Chekhov video, it was indicated that it took 40 minutes to charge up the craft to experience levitation. Consider the high voltage circuit KT8148 transistor specification VBE equal to 0.6 volt. Transistor base voltage at the voltage divider VB equal to 12 volt times 47 meg divided by 47 meg plus 10k equal to 12 volt times 47k divided by 47 meg plus 0.01 meg equal to 11.9974 volt DC. Current available to the secondary winding of the Tesla coil IB equal to VB minus VBE divided by 10k parallel 47 meg equal to 11.9974 minus 0.6 divided by 0.01 times 47 divided by 47 plus 0.01 equal to 11.03974 divided by 0.00998 meg. Note, 10k is equal to 0.01 meg. The answer is 1139.9680 milliampere. Note, to the transistor space, it sees two branches. Resistors are at parallel at the branch node. In 40 minutes, the base would have supplied 1139.9 fission greater than 1 coulomb to charge up the craft to experience levitation. Alex Chekhov high voltage power supply. I withdraw the Alex Chekhov high voltage circuit as below for circuit analysis. The original circuit indicated in handwriting somewhat looked like KT819. After checking with transistor datasheet, I found the transistor to be KT814A PNP manufacturer Integral Corp. Technical specification exert as below. VEB maximum equal to 5 volt. VCE saturation equal to 0.6 volt. In order to analyze the circuit, I need to add some node numbers A, B, C until G to circuit for identification. Node AF are where the capacitor is, C equal to 2200 microfarad. Node BE is where the voltage divider is. Node G is transistor space. Node BC are the same point. C to emitter is primary coil of the Tesla coil. Node G to D is secondary coil of the Tesla coil. Node A. When the 12-volt battery is on, node A will start to charge up the capacitor C, and its voltage small v shall start from 0 to V as the capacitor charge up. Node B. The voltage at B equal to 12 minus V. Initially, when V equal to 0, VB equal to 12 minus 0 equal to 12 volt DC. Node G. the voltage divider voltage equal to 47 meg divided by 10K plus 47 meg times 12 volt equal to 47 divided by 47.01 meg times 12 equal to 11.9974 volt DC. At this voltage, KT814A transistor is turned off due to reversed bias between the base and emitter. The collector would be zero current, IC equal to 0. KT814A equal to off. Base to emitter is clamped at VBE max equal to 5 volt as specification. Due to voltage difference, VG minus VBE max equal to 1 to 11.9974 minus 5 equal to 6.9974 volt DC. This 6.997 volt DC shall cause a current flow from the node G into the secondary coil of the Tesla coil to node D. As soon as a current flows through the secondary Tesla coil, it operates in the reverse step down. The primary coil shall have low voltage, 12,000 volt divided by 1,000 equal to 12 volt DC, like an open circuit wire. Yet, as long as node A capacitor volt V is small at time equal to 0, transistor equal to off, collector IC equal to 0. After some time, the capacitor shall be charged up. Small v shall become big V, equal to 12 volt DC, or at least 0.6321 times 12 equal to 7.5852 volt DC. Node B shall become 12 minus 12 equal to 0 volt DC, or 12 minus 7.58521 equal to 4.4179 volt DC. This is less than VEB max 5 volt. KT814A is on. Then current cannot flow through the voltage divider. VB equal to 0 volt. VG equal to 0 volt DC. VB equal to 4.4179 volt DC. VG is less than 5 volt DC. As the VG goes low, below 4.4179 volt DC, it shall cause the transistor KT814A emitter to base a forward bias voltage. Transistor turns on. Then the collector IC max equal to 1500 milliamp per specification shall flow through the primary coil, Tesla coil, and it shall step up, induce a high voltage HV supply to the larger disc nano-coated aluminum. This IC max current demand shall drain off the voltage in the capacitor C equal to 2200 microfarad. Until the voltage falls back to small v, the capacitor shall have to recharge again. This process, capacitor charging up, transistor off, to capacitor discharge down, transistor on, These actions go on oscillation. The current charging, discharging the Tesla coil. High voltage transformer experience a simulated AC alternating current. Hence, supply high voltage to the larger disc, nano-coated aluminum. Basically, the battery is there to supply DC to support the bias voltage of the transistor on-off. The Tesla coil transformer works on simulated alternating current. The capacitor voltage V is called small signal. RC constant of the high voltage circuit. In this circuit, I marked in purple lines as discharge current flow, blue lines as charging current flow. Although resistors are non-directional, the direction of current through the resistors are controlled by voltage, potential difference, and the switching on-off of the transistor. To the input Tesla coil primary, it is the discharging current flow that makes the high voltage works. To the output of the Tesla coil secondary, it is the charging current flow makes the high voltage current works. Oscillation is between primary and secondary of the Tesla coil transformer. The small v is a variable. It contributes to a simulated alternating current I, referred to as small signal. The voltage V change in the capacitor C is Q equal to C times V by definition of capacitance. Taking the calculus differentiation in time, dq dt equal to C times dV dt. By definition, Q dq dt equal to I. Therefore, I equal to C V dV dt. In the discharge circuit, the capacitor C is charged up. Node A, small v, has become big V, close to E equal to 12 volt DC. The battery current cannot flow. A simulated battery off. Tesla coil transformer T1. Primary winding has 5 turns and no resistor R or inductance L to talk about. No data, R equal to 0, L equal to 0. All the capacitor voltage is dumped through the Tesla coil primary into the resistor. R equal to 47 mega ohm. Voltage equal to IR. So the discharging circuit A, B, C, G, E, F is reduced to a capacitor resistor RC series circuit. R plus IR equal to 0. V plus C dV dt times R equal to 0. V dt plus RC dV equal to 0. V dt equal to minus RC dV. dV divided by V equal to minus 1 over RC dt. Continue from previous slide. dV over V equal to minus 1 over RC dt. The capacitor is a voltage device. Q equal to C times V. It takes a voltage to discharge down. The current I equal to dq dt is an instantaneous current I in the circuit. Soon it be taken by the resistor as voltage I times R. Taking calculus integration, discharge from V sub 0 to V volt. Integrate dV over dV equal to integrate minus 1 over RC dt. Natural log V minus natural log V sub 0 equal to minus T over RC. Natural log V over V sub 0 equal to minus T over RC. Taking the inverse of natural log V over V sub 0, V is equal to V sub 0 times exponential minus T over RC equal to V sub 0 e to the power minus T over RC, a discharge curve RC in series. When T equal to RC, the term exponential minus T over RC becomes e to the power minus 1 equal to 0.3679. V equal to 0.3679 V sub 0. That is, the voltage V equal to 0.3679 V sub 0 is 36.79%. Is considered low enough for the capacitor is practically discharged. Say, when the capacitor is fully charged to 12 volt, V sub 0 equal to 12, V equal to 0.3679 times 12 equal to 4.4148 volt DC is fully discharged. This T equal to RC is called a time constant. The process repeats in the circuit. Discharge T equal to RC is a time period. T discharge equal to RC equal to 47 meg times 2200 mil equal to 103,400 seconds. Mil and meg cancelled. The frequency of the discharge equal to 1 over TD equal to 1 over 103,400 equal to 9.6712 e to the power minus 9 per second equal to 9.6712 mil hertz. This is very low frequency. Similarly, in charging up, the circuit is nodes A, B, E, F. I marked dotted line to complete the charging circuit. Because the charging current, which goes to supply high voltage to the larger disk, it is not exactly returned by the dotted line. Yet, there are plenty of electrons available in the battery to complete the circuit. E minus small b equal to IR equal to C times dV dt times R. E equal to 12 volt. I is current into 10K resistor because transistor is off. E minus small v dt equal to RC dV. dV divided by E minus V equal to dt divided by RC. dV over V minus E equal to minus 1 over RC dt. Taking the calculus integration from V to E equal to 12 volt DC. Integrate dV over V minus E equal to integrate minus 1 over RC dt. Please integrate U divided by U equal to integrate minus 1 RC dt. Change variable. Integration U equal to V minus E. du equal to dV. Lateral log U equal to minus T divided by RC. Substitute U equal to natural log V minus E equal to log V minus log E equal to log V over E. Note, taking the difference of the natural log is division. Taking the inverse of natural logarithm, V over E equal to exponential minus T over RC. That is, V equal to E times E to the power minus T over RC. E equal to 12 volt DC. Note, this result is same as the discharge curve because R is parallel to C. The resistor in effect is 10K. Then, charging time constant Tc equal to Rc equal to E to the power minus 1 equal to 0.3671 V equal to 12 times 0.3671 equal to 4.4052 volt. Tc equal to Rc equal to 10K times 2200 mil equal to 22 seconds. The frequency of charging equal to 1 over Tc equal to 1 over 22 per second equal to 0.04545 Hz. This calculation indicated that the capacitor is 36.71 charged up. In combined effect, charging-discharging, the charging frequency dominates. Frequency equal to 0.04545 Hz. The mu Hz is ignored. This calculation indicated that the Alex-Chekhov high voltage circuit oscillates in very low frequency. On the internet, I found the definition of Tesla coil, which indicated a mini model could produce high voltage HV in the range of 4,000 volt to 10,000 volt. In Alex Chekhov video, I noticed that the primary coil N1 equal to 5 turns. The battery is 12 volt. VCE saturation equal to 0.6 volt. KT 8148 specs. This means when the KT 8148 transistor is on, IC maximum equal to 1500 milliampere equal to 1.5 ampere specifications. The voltage across the primary coil shall be 12 minus 0.6 equal to 11.4 volt DC. So as I take my assumption that the input to be 12 volt, the output to be 12 kV, then T1 Tesla coil would have secondary coil N2 equal to 12,000 divided by 12 equal to 1,000 turns. N1 equal to 5. N2 equal to 1,000 turns. Full load current of transistor IC max equal to 1.5 ampere. N1, the primary winding, has 5 turns. It needs to stay in shape. Not to touch the secondary winding, I suggest use N1 AWG14 equal to 1.6 mm diameter, 8 ampere capacity. N2 secondary can be wound with AWG20 equal to 0.81 mm diameter, 2 ampere. Diameter of Y size. Diameter of winding N1 equal to 2 inch equal to 50.8 mm. N2 equal to 1.5 inch equal to 38.1 mm. Capacitor specifications. Electrolyte aluminum capacitor. Technical specifications as below. I equal to inserted type. It requires a capacitor holder for insertion. The outcome of my analysis on the Alex Chekhov high voltage power supply circuit is this. Parts required. Battery 12 volt DC, 1 number. Capacitor inserted 2200 microfarad, 16 volt, 1 number. Holder capacitor, 1 number. Resistor, trim port, 51k ohm, 1 number. Resistor, 47 mega ohm, 1 number. Transistor, PNP, 1 number. Tesla coil, HV transformer, N1 equal to 5, AWG14 equal to diameter 1.6 mm, 50 mm diameter, N2 1000, AWG20 diameter 0.81 mm, 38 mm diameter. Alex Chekhov low voltage power supply. In this circuit, I take the assumption that the center tapped transformer input is supplied with plus minus 12 volt. The output is multiple of input at 480 volt is the high voltage, above 300 volt is high voltage. When compared to the Tesla coil at 12,000 volt. So I label this as the low voltage LV power supply. For circuit analysis, I take KT814A PNP transistor, VEB maximum equal to 5 volt, VCE saturated equal to 0.6 volt, IC max equal to 1500 milliamp equal to 1.5 ampere. KT815A NPN transistor, VEB max equal to 5 volt, VCE saturate equal to 0.6 volt, IC max equal to 1.5 ampere. Manufacturer Integral Corporation. I redraw the circuit as below for circuit analysis. The original circuit is missing resistor values. Could it be R1 equal to R2 equal to 10k ohm? R3 equal to 10k ohm also? I need to verify them. Z1 is Zener diode. D is rectifier diodes. C's are for DC filtering. Technical specifications to be determined. Due to similarity to the previous high voltage circuit, I set R1 equal to R2 equal to 10k ohm. When the battery E is equal to 12 volt DC, the battery on, the 2200 microfarad capacitor C is charging up. Its voltage V would be Q equal to C times V, at the time 0, t equal to 0, V equal to 0. The circuit would start with E equal to 12 volt DC. For circuit analysis, I mark node numbers A, B, C until N. I and J are not used to avoid confusion with current I. Q1, Q2, Q3 to identify transistors. At time equal to 0, node B is E equal to 12 volt DC. R1 supplies current to the emitter of the transistor Q1. R2 supplies to base of Q1. Both voltages are as high as node B. At the state of high, voltage shall keep Q1 equal to off. At node M, high state shall put Q2 to forward bias. Being NPN, Q2 equal to on. In order to stay on, the base has to be 0.6 volt lower than emitter. Specs VEB equal to 0.6 volt. How high is high? It could be high as 12 volt DC when no current flow to R1, when Q1 equal to off. Therefore, node H, VH maximum equal to 12 volt minus 0.6 volt equal to 11.4 volt DC. When Q1 is off, VM equal to VEB max equal to 5 volt. Therefore, VHM minimum equal to VM minus 0.6 equal to 5 minus 0.6 equal to 4.4 volt DC for Q2 equal to on. This calculation indicated that VK has to cover the range VH max and VH minimum equal to 11.4 minus 4.4 equal to 6 volt DC. VK equal to 6 volt. VK equal to 6 volt gives an indication about the Zener diode. Is at 1. It should be 6 volt DC to keep VK constant at 6 volt DC. On the internet, alldatasheet.com, I found suitable VD is at 6.2B Zener diode, 6.2 volt. I is at equal to 5.0 milliampere. Manufacturer Rowe Semiconductor. Continue analysis. When VK is clamped at 6 volt, current through 51K resistor equal to 6 divided by 51K equal to 0.1176 milliampere. Current through 47 mag resistor equal to 12 minus 6 divided by 47 mag equal to 0.1277 microampere. Verified within VD is at 6.2B limit. L is at equal to 5 milliampere. The setting of 51K trim port adjustment required. When 51K is set to X, then VH equal to 6 times X divided by 51 equal to HM minimum equal to 4 volt DC. X equal to 4.4 times 51 divided by 6 equal to 37.4 k ohm. When 51k is set to Y, then Vh equal to 6 times Y divided by 551 equal to Vh maximum equal to 11.4 volt. Imply that Y is equal to 11.4 times 51 divided by 5 equal to 116.28 kilo ohm. This is not used because maximum resistance setting is 51 k ohm. When Q2 is on, node C shall draw a full load current IC maximum equal to 1500 milliampere equal to 1.5 ampere as Vh minimum equal to 4.4 volt. Vm equal to 4.4 plus 0.6 equal to 5 volt. VCE saturation equal to 0.6 volt. So node C, R3 has to shunt the current 1 IC maximum equal to 1.5 ampere. Therefore, I set IC equal to 0.1 ampere. IR3 equal to 1.4 ampere. Then 5.6 V divided by 1.4 ampere equal to R3 equal to 4 ohm. Wattage of resistor equal to 5.6 V volt times 1.4 ampere equal to 7.8 watt. Upgrade to R3. When transistor Q2 is on, it causes a current flow out of the transformer T2 from D to G, as well as from C to H. As current flow out of the center tap, it creates an equal and opposite voltage at node E, that is plus VE equal to 5.6 volt DC by T2 transformer's internal induction. Hence, transistor Q3 base to emitter is forward biased. Q3 equal to on. When transistor Q3 is on, it causes a current flow out of the transformer T2 from D to F to G. This current flow reverses the flow in D, thus cause current flow reverse in the center tap, and a negative VE equal to minus 5.6 volt DC at F. Therefore, the transformer T2 runs at plus minus 5.6 volt equal to 11.2 volt AC, a simulated alternating current. Current goes in reverse at D. C causes Q2 to turn off because PNP transistor is in favor of current into collector. So Q2 equal to on, Q3 equal to on, Q2 equal to off, Q1 equal to off. When node E is 5.6 volt DC, current through the 1k ohm resistor equal to 5.6 volt divided by 1k equals 5.6 milliampere.
This is the Black Thanos,
Q3
Black
specifications.
right now.
Okay.
Yeah.
The next round of operation is when the capacitor C equal to 2200 microfarad is charged up. T equal to time constant RC. The voltage V becomes a big V. This E minus V voltage goes low, inhibits the current flow to M. Therefore, Vm goes low, and so Q1 transistor becomes a forward biased. Q1 equal to on. This opens a path for current to flow out of Q1 collector from node C to D into transformer T2. The current flow out of from Q1 collector, it reverses the current flow at node C to Q2 collector, encourage Q2 to turn off. Also, Vm goes low. Vh minimum equal to 4.4 volt. Therefore, Q2 equal to off. Likewise, current flows from node C to D produces a plus 5.6 volt DC at node E, which keeps Q3 equal to on and produce minus 5.6 volt DC at node F. Once again, T2 transformer experiences a simulated alternating voltage plus minus 5.6 V DC. Q1 equal to on, Q2 equal to off, Q3 equal to on. Keeps T2 to continue operation. T2 transformer primary equal to 11.2 volt AC simulated alternating current. The capacitor C equal to 2200 microfarad is charging up. Q1 equal to off, Q2 equal to on, Q3 equal to on. So basically R2 equal to 10k ohm, taking the current to Q2 equal to on. That affects the capacitor charging. 47 meg ohm is taking small current in microampere, can be ignored. Charging circuit, Q1 off, Q2 on, Q3 on. We have E minus V equal to IR equal to C times dV dt. Then, as calculated in previous slide, V equal to E times e to the power minus T divided by RC. Setting R equal to R2 equal to 10k, the time constant Tc equal to R2 times C equal to 10k times 2200 microfarad times equal to 22 seconds. Frequency equal to 1 over Tc equal to 1 over 22 seconds equal to 0.04545 Hz. Discharging circuit, Q1 equal to on, Q2 equal to off, Q3 equal to off. On discharging capacitor, C equal to 2200 microfarad, R equal to R1 equal to 10k, R3 equal to 4 ohm is ignored. We have V plus IR equal to 0, V equal to minus C dV dt times R, imply that dV over V equal to minus 1 over RC dt. Then, as calculated before, V equal to V naught e to the power minus T over RC. Setting R equal to R1 equal to 10k. The time constant Td equal to 10k times 2200 mil equal to 22 seconds. Frequency equal to 1 over Td equal to 1 over 22 seconds equal to 0.04545 Hz. Once again, this calculation indicated that the low voltage circuit is operating in very low frequency. Coming back to discuss T2 transformer. Initially, I set transformer input as 12 volt AC, output 480 volt. Then the transformer turn ratio N equal to 480 volt divided by 12 volt equal to 40. Now that the calculated input is plus minus 5.6 volt, the input equal to 11.2 volt AC. The output of T2 equal to 40 times 11.2 equal to 448 volt AC. 448 volt versus 480 volt is 448 divided by 480 equal to 0.933 or 93%. That is 6.67% voltage variation acceptable. After the T2 transformer, the circuit can be redrawn, transformed into a half-wave rectifier circuit. The transformer output is simulated 480 volt AC, calculated 448 volt AC. D1, D2 forms a half-wave rectifier. Then C1, C2, D1, D2 formed a rectifier bridge circuit. Capacitor C1, C2 are used due to low frequency operation, 0.04545 Hz. At high voltage 480 volt AC operation, that ordinary diode cannot take it. Low frequency, high voltage. D is current flow directional guide, leading current flow back to negative. The C3 and C4 are capacitors in series for voltage stabilization. D is equal to 1N4004 diode. The rectifier circuit is operating in low frequency, F equal to 0.04545 Hz. I need C1, C2 to give low reactance. I set XC equal to 1 ohm. XC equal to 1 over omega C equal to 1 over 2 pi frequency C equal to 1 over 2 times 3.1416 times 0.04545 times C. C equal to 0.3 farad is very large, not suitable. The smallest electrolyte capacitor low frequency use available for 400 volt may be 68 microfarad. Then Xc equal to 1 over 2 times 3.1416 times 0.04545 times 68 times 10 to the power minus 6 equal to 51,496.3343 ohm equal to 51 k ohm. Notice, it is better to use a small capacitor in the rectifier circuit. It makes very odd to have a small diode to drive a physically big capacitor. Therefore, I set C equal to C1 equal to C2 equal to 68 microfarad 400 volt. C3, C4 equal to 150 microfarad 250 volt, the smallest I found. Manufacturer Rubicon. Transistor KT814A, KT815A specifications. IC maximum equal to 1.5 ampere. VA in transformer T2 primary equal to 1.5 times 11.2 equal to 16.8 VA. Therefore, maximum current in the rectifier circuit equal to 16.8 VA divided by 448 volt equal to 0.0375 ampere equal to 37.5 milliampere. This indicated that I can use a 1 amp diode to support the rectifier function. On the internet, I found this capacitor suitable. C1 equal to C2 equal to 68 microfarad, 400 volt DC. I could not find 500 volt DC at this time. Note: 400 volt DC capacitor for reliability, not to have high voltage short circuit. Manufacturer Rubicon. C3 equal to C4 equal to 150 microfarad, 250 volt DC. Note: 2 times 250 volt DC capacitor for voltage regulation, maximum 500 volt DC. Transistors KT814A, KT815A specifications. IC maximum equal to 1.5 ampere. VA in T2 primary equal to 1.5 times 11.2 equal to 16.8 VA. T2 upgrade to 20 VA. Therefore, maximum current in rectifier circuit equal to 16.8 VA divided by 448 volt equal to 0.0375 ampere equal to 37.5 milliampere. This indicated that I can use an 1 ampere diode to support the rectifier function. D equal to D1 equal to D2 equal to 1N4004 diode, 400 to 480 volt, 1 ampere, suitable. Manufacturer ON Semiconductor. www.onsemi.com. Alex Chekhov low voltage power supply. This is the outcome of my analysis on the Alex Chekhov low voltage power supply circuit. Power parts required: battery 12 volt DC, 1 option. Capacitor 2200 microfarad 16 volt, 1. Holder capacitor, 1. Zener diode 6.2 volt DC, 5 milliampere, 1. Resistor 47 mega ohm, 1. Resistor trim port 51 k ohm, 1. Resistor 10 k ohm, 2. Transistor PNP KT814A, 2. Transistor NPN KT815A, 1. Resistor 4 ohm, 10 watt, 1. Resistor 1 k ohm, 1. Transistor transformer 12 volt to 480 volt step-up transformer, 20 VA, N equal to 40. plus minus 5.6 volt center tap 1. Continue with half-wave rectifier circuit on the Alex Chekhov low voltage power supply circuit. Half-wave rectifier circuit. Parts required. Capacitor 68 microfarad 400 volt DC 2. 1N4004 diode 400 2 numbers. Aluminum large disc below for circuit analysis. The original circuit indicated in handwriting. Somewhat rectifier circuit. Parts required. Capacitor 68 microfarad 400 volt DC 2. 1N4004 diode 400 volt 1 ampere 3. Capacitor 150 microfarad 250 volt 2. Alex Chekhov demagnetizer circuit. This circuit has not a capacitor for charging discharging. This circuit shall oscillate in its natural frequency, as according to transistor specifications, Ft equal to 40 MHz. As per previous calculation in low voltage circuit, Z1 equal to VDZ 6.2 B 6 volt DC limit IZ equal to 5 milliampere 51K variable resistor trim port setting equal to 37.4 k ohm. This sets Q1 base to 4.4 volt DC. Q1 equal to on. Current flow out from the emitter into T2 transformer center tap, which induce a plus voltage, a forward bias for Q2 equal to on. Collector current draws in reverse current flow in T2 center tap, which induce plus voltage to Q1 emitter. Q1 equal to off. Reverse current sets Q2 base minus. Q2 equal to off. And this process repeat. Q1 equal on. Q2 equal on. Q1 equal off. Q2 equal off. Circuit in continuous oscillation. This circuit stays on the ground. It may be used to demagnetize the environment that may affect charging up of the lift craft. It may be used to assist the nano-coating process of the nano-coated aluminum disc. After lift-off the nano-coating, this magnetizing circuit shall have no continuing function. Alex Chekhov demagnetizer circuit. As shown in the picture, I could identify the demagnetizer circuit coil and the T2 step-up transformer. 12 volt, 480 volt, marked up in orange arrows. Parts required for this circuit. 12 volt DC battery, 1 option. Zener diode. VD is at 4.62 B, 6.2 volt DC, 5 milliampere, 1. Transistor NPN, KT8158, 2 numbers. Transformer N equal to 40. 12 volt AC, center tapped, plus minus 5.6 volt AC. 480 volt, 20 VA, 1. Coil, 480 volt AC, 75 milliampere, 1. resistor 47 mega-ohm 1, resistor trim port 51K 1, resistor 1K ohm 1. Power supply connections. The picture indicated the connection points for the plus low voltage and minus low voltage, which are the tilted copper strip contacts. For longer time reliability, maybe to use commutator carbon brush contacts. The plus high voltage connection point is fixed onto one of the support mounting posts. Note, this information is from Alex Chekhov test model. Electrostatics. Our winter weather experience with electrostatics is that tingling, spark, shock feeling when we touch electrostatics. In this picture, it indicated Alex Chekhov he could touch the support post of the craft. There was no electric shock to his touch. This may be because the transformer output T1 is 448 volt. 1.5 times 11.2 VA divided by 448 volt equal to 0.0012 ampere equal to 1.2 milliampere. Transformer output T2 is 12,000 volt. 1.5 times 11.2 VA divided by 12,000 volt equal to 0.0014 ampere equal to 1.4 milliampere. Both are very small current. Electrostatics are also known to be vulnerable to moisture, humidity of the air. It could drain off discharge, render the craft to have no levitation. Would this craft operate in rainy days? This is yet to be verified by tests in different weather conditions. Payload of the craft. Up to this slide, my analysis indicated that this Alex Chekhov lift craft could be a promising technology to develop into citizen flying cars, citizen flying saucers, and citizen space vehicles. The answer on how to develop may be in Alex Chekhov research. Transformers all stay on the ground. The next step is to test in all weather conditions. Would electric field is false. It was calculated the craft could lift up to 39.1834 kilograms at 10-meter height. In theory, the Alex Chekhov craft could carry the battery, electronics, boxes, transformer onto a platform. In Alex's video, it did not seem to take a lot of force to pull his craft down. There may be due to electric field is different, voltage supplied, Coulomb charged in converting the electrostatic force. Test flying platform. After pass all weather conditions tests, the load test, the payload may be increased by combining 4 units of the Alex Chekhov lift craft installed with external cover for electrostatic protection to avoid electrostatic shock and mechanical damages. With 4 units, it could in theory support 4 times 39 equal to 156 kilograms, a payload with a passenger. The lift craft unit at the center to be the main support for the test platform. After levitated, the front units for the deceleration, braking, rear units for steering, acceleration, 4 units to operate simultaneously for levitation and altitude control. After airborne, anti-gravity dynamic weight becomes effective. It shall free up the triangular located lifter units, rear for steering, acceleration, and front units for deceleration. As in all human endeavor, safety is first. Initially, we need to work on making the platform stable to operate in all weather conditions at low altitude. Even 6 inches above the ground is still a flying platform. Keep in low altitude, like 6 inches, should be safe. To emergency and landing, to blend in our existing roads and highways, to create 3-dimensional highways. Other than to fly thousands of feet high, it could be like an airplane. Citizen flying car. After past tests on flying platform, at a rooftop and 4 landing gears shall be a citizen flying car. The landing gear may consist of ring magnet type of ball bearing with rubber tire coating so that it can absorb the landing impact and brake by eddy current, with the ball bearing roll along its landing path. The flying car would have to have levitation controls to create us 3-dimensional roads and highways. It would have to switch lanes between some specified vertical lanes at level heights such as 6 inches, 152 mm, 16.4 feet, 5 meters, and 32.8 feet, 10 meters, as well as horizontal, left lane, right lanes. The forward acceleration steering, reverse deceleration braking may be controlled by tilting the lift units, similar to described by Bob Lazar as Omicron mode. Citizen flying saucer. Another technological level of operation is citizen flying saucer. It can vertically take off to fly up to high altitude like an aeroplane, or even like a spaceship fly to space with the Alex Chekhov liftcraft principles, using ordinary commonplace materials, batteries, transistors, resistors, aluminum, magnets, Tesla coils, and transformers. Citizen flying saucer need to have sophisticated navigation systems, yet our world already have GPS, sophisticated navigation systems for aeroplanes and spaceships, and even autopilot systems for cars. Branding in these systems into the citizen flying saucer, voila, it shall be a great achievement for humanity. To fly out to space to another planet, the citizen flying saucer need to have high speed to achieve escape from Earth's surface equal to 1.12 times 10 to the power 4 meter per second, 25,518 miles per hour. Earth surface to Mars surface and return, equal to 3.4 times 10 to the power 4 meter per second, equivalent to 77,464 miles per hour. Plus, we need sophisticated environmental control systems, air pressure, air conditioning. We already have them in our aeroplanes, space stations. So all this indicated a possibility to achieve citizen flying saucer. Citizen space vehicle. We all love the aerospace shape of a car, with distinguishable head and tail, being rectangular, have compartment space to move around, have privacy with hi-fi music for enjoyment. As more of these wish list features add on to the citizen space vehicle, it would add on payload weight, speed, power requirement. 3 liftcraft units may be assembled into one. Then each combined unit may carry 3 times 39 kg equal to 117 kg. 4. 3 times 4 combined may carry 4 times 117 kg equal to 468 kg, and so on, to meet the payload demand. Note: vacuum space propulsion, point liftcraft units to nearby planet for e-fuel interaction. The Alex Chekhov liftcraft starts with one battery, 12-volt DC, 480-volt, 12 kV. The world's Tesla Roadster car used 6,000 pieces AA lithium batteries, 215 kilowatt. As asymmetric capacitor lifter used 30 kilovolt. T. Townsend Brown effect used 100 kilovolt. We have options already available for continued research to increase the power and speed for each payload to develop a citizen space vehicle. I wish automobile industrial companies, airplane aviation companies, aerospace companies would look into it for continued research. In summary, the Alex Chekhov liftcraft required these parts: magnet, DX08 N42, 1-inch diameter, 0.5 inches thick, 12 numbers. Magnet mount, 1-inch diameter, number 8-32, male thread stud, 12 numbers. Motor, 12-volt DC, 7,380 RPM, 2 numbers. Aluminum CD disc, 12 cm diameter, 0.1 mm thick, 2 nano, 2 numbers. Aluminum large disc, 24 cm diameter, 0.1 mm thick, 2 nano coat, 1 number. Steel rod, screw thread, 4 mm diameter, 250 mm length, 3 numbers. Nut, female, 4 mm diameter thread, 18 numbers. Washer, 4 mm inner diameter, 18. Rubber cushion, 4 mm inner diameter, 6 numbers. The outcome of my analysis on the Alex Chekhov high voltage power supply circuit is this. Parts required: battery, 12 volt DC, 1 number. Capacitor inserted, 2,200 microfarad, 16 volt. 1 number. Holder capacitor, 1 number. Resistor, trim port, 51k ohm, 1 number. Resistor, 47 mega ohm, 1 number. Transistor, PNP, 1 number. Tesla coil, HV transformer, N1 equal to 5, AWG14 equal to diameter 1.6 mm, 50 mm diameter, N2 1000, AWG20 diameter 0.81 mm, 38 mm diameter. Alex Chekhov low voltage power supply. This is the outcome of my analysis on the Alex Chekhov low voltage power supply circuit. Power parts required. Battery 12 volt DC, 1 option. Capacitor 2200 microfarad 16 volt, 1. Holder capacitor, 1. Zener diode 6.2 volt DC, 5 milliampere, 1. Resistor 47 mega ohm, 1. Resistor trim port 51k ohm, 1. Resistor 10k ohm, 2. Transistor PNP KT814A, 2. Transistor NPN KT815A, 1. Resistor 4 ohm, 10 watt, 1. Resistor 1k ohm, 1. Transistor transformer 12 volt to 480 volt step-up transformer, 20 VA, N equal to 40, plus minus 5.6 volt center tap, 1. Continue with half-wave rectifier circuit on the Alex Chekhov low voltage power supply circuit. Half-wave rectifier circuit. Parts required. Capacitor 68 microfarad 400 volt DC, 2. 1N4004 diode 400 volt 1 ampere, 3. Capacitor 150 microfarad 250 volt, 2. Alex Chekhov demagnetizer circuit. As shown in the picture, I could identify the demagnetizer circuit coil and the T2 step-up transformer. 12 volt, 480 volt, marked up in orange arrows. Parts required for this circuit. 12 volt DC battery, 1 option. Zener diode, VD is at 4.62B, 6.2 volt DC, 5 milliampere, 1. Transistor NPN, KT815A, 2 numbers. Transformer N equal to 40, 12 volt AC, center tapped, plus minus 5.6 volt AC, 480 volt, 20 VA, 1. Coil 480 volt AC, 75 milliampere, 1. Resistor 47 mega ohm, 1. Resistor trim port 51K, 1. Resistor 1K ohm, 1. Caution: high voltage 12,000 volt is known to produce electric sparks, touching metal surfaces and earthing to earth ground. Caution must be taken to not touch any of the wiring in the circuit. Check all wiring terminations, screws tightened, wires securely fastened, cables properly insulated prior to power on to prevent electrical arcing, prevent current leakage. The circuit boxes must have label high voltage 480 12,000 volt AC to alert end users. Test site to be posted with high voltage 480 12,000 volt sign. Testing, servicing, repair, maintenance to be done by experienced, qualified personnel. Keep out of children, keep out of aerosol, flaming items, flammable items away from the test site. Test benches. Take same precaution as we would for any electrical appliances. Test protocol is necessary to be planned out on human safety issues. Crashes, landing damages, loss of craft, countermeasures to stay in low altitude, 6 inches from the ground until balancing full control is achieved. Conclusion. These analyses indicated that the Alex Chekhov lift craft is estimated to weigh 1.5892 kilograms. It could lift itself up with force 15.5742 newtons. The counter-rotating magnets, its main function is to distribute electrons towards the disk centers and rims. Its second function is to reduce the dynamic weight of the magnetic pairs by 25%. The CD discs and large discs, they have different diameters. It opens up the electric field E, giving a positive vector upward. The electric field in volts per meter has the same dimension units in newtons per coulomb. Hence, the bottom disc charged with negative repels the Earth-ground electrons. The Earth is a huge reservoir of electrons. It won't be pushed. The lift craft has to levitate to get away from the reaction. The electric field E follows an inverse square law. It is calculated that at 10-meter height, the electric field E would have weakened by 1/100. After discounted the distance, height from the Earth ground, the electric field E would support 39 kilograms at 10-meter height. Electrostatics are known to be very vulnerable to moisture, humidity of the air. It could drain off, discharge, render the craft to have no levitation. Would this craft operate on rainy days? Is it yet to verify by tests in different weather conditions? In this analysis, it is indicated that the Alex Chekhov lift craft working principle is electrostatics. The electric field E is voltage V, electrode separations S. Knowing these factors, E equal to dV over ds. The lift craft can be scaled to make bigger into propulsion units to support payload to become flying vehicles. To use bigger discs, the bigger disc area A, the more charges it can contain, the more force it can produce, as F equal to Q times E for bigger units. There is a lot to do to stabilize multiple lift craft units, to use it for flying car, flying saucer, and space vehicle. So is to use it for propulsion by tilting the units to work in Omicron mode. 40 minutes charging time appeared to be quite long for a citizen flying car. When this Alex Chekhov liftcraft technology working principle is confirmed, replicated, the charging time can be improved by more current delivery from the low voltage and high voltage power supplies. As a start, this analysis indicated 1139.968 microampere. By using power electronics interface with IGBT's insulated gate bipolar transistors circuitry, it may increase the current delivery. Charging time may be improved. Thank you for watching. This completes my presentation. I wish this presentation to be useful to the knowledge seekers for continued research and development into citizen flying cars, citizen flying saucers, citizen space vehicles, for electrical engineers and students to understand my interpretation, quantification of anti-gravity, levitation, and the mathematics involved, applying mechanics, electrostatics, electromagnetics, and electronics in the analysis of the Alex Chekhov liftcraft from an experimental model test result, from textbooks and other video data transferred to a concise reference. Thank you, Alex Chekhov. Thank you, 德国板草茶 my tea. Thank you, Lee Memphis. Thank you, J&K Magnetics. Thank you, Boyd Bushman. Thank you, AK Lectures. Thank you, Banggood.com. Thank you, Magifit. Thank you, AllDataSheet.com. Thank you, OnSemi.com. Thank you, Rubicon. Thank you, Panasonic. Thank you, Bob Lazar. Thank you, Discovery Channel. Thank you, Dr. Robert G. Jan. Thank you, Dr. Paul Laviolette. 谢谢你，盛佑宇博士。Thank you, Dr. Paul Parsons. Thank you, YouTube. Thank you, knowledge seekers. Thank you, my wife Doris. Have a good day. Peace to the world. My personal spaceship, Fuel Plasma Space Travel 1, presented by Man Tim Lee, June 2017. I wish to share with the knowledge seekers that I made a personal spaceship as per photographs. I achieved space travel at the fuel plasma level. My personal spaceship stayed in my study room. My body was in bed. Images came to me in closed eyes condition. Seconds before I opened my eyes to wake up. These images appeared for 4 seconds to 30 seconds. 2017, January 1st, Sunday. This morning I saw a display like a three-dimensional map. The African continent on the left, India continent on the right. There appeared a big fish, buoyant on the ocean. The rear ventricle fin